Hello, I'm Dulcidi Coelho. I'm going to speak to you about the building monitoring and diagnostic services. This work is a collaboration between SmartGateways and SPA. Both companies work in the domain of the Internet of Things, where we explore elements around interoperability, be it at the hardware level, where we look at how we can bring a range of different sensor networks within the same platform, and also providing different alternatives to expose that data so that it can be integrated in current building management systems as well. So, of course, this approach has a higher flexibility, allowing again the integration of sensors of different nature, and also scalability, allowing older closed systems to be expanded and integrate new functionality. The main aim of this service was to create an integrated solution to monitor the energy consumption and comfort parameters in order to verify that the achieved improvements through the renovation process don't degrade over time. A set of requirements was required for this platform. On one side, to be an open solution that would integrate heterogeneous sensor networks, provide a RESTful API to allow a seamless integration with the ENCORE platform, be a low-cost integrated software hardware integrated platform with low technical installation requirements so that it could be installed by anyone without any specific training, and also to create an effective dashboard to monitor the sensor's data. The created solution is based on the Smart Gateways platform architecture. This is a multi-layered architecture that allows day-to-day devices to be used within the same control network. As an example, uh, a sensor is connected to the platform through its own middleware, so it doesn't really care about what is the technology behind it as long as there is an appropriate middleware for this sensor. Is turned into a virtual object, so its properties and data is stored as a software object. This allows it to be used within an agnostic control network that then can be fed that information to an actuator, in this particular case the boiler. This information is also available through a cloud interface, allowing the connection with third-party services, allowing again the control loops to be executed from third-party applications. One critical element for the solution is the element used to sense not only the energy consumption but also the environmental factors. So one of the supported elements is smart meters. These are both electric and gas. So the current platform supports MBUS and PLC technologies. An alternative, we can use pulse detectors, so which are only available for electric meters. Smart plugs allow the control and monitoring of individual energy devices like heaters, for example. Um, Clamps, so these measure the current that's going through cables, so we can individualize which elements to monitor, and also elements to be put on the power panels that allows the individual measurement of power consumption within an electrical installation. For environmental factors, we supply to this project a variety of sensors, one that is able to measure temperature, luminosity, and movement, so good to assess user behavior within certain spaces. Other allows us to measure temperature and relative humidity, and we can also monitor air quality like volatile organic compounds and CO2 and carbon monoxide as well. The installation of the platform is pretty straightforward. The platform itself, or the solution, contains a gateway and a range of sensors that can be paired with it. So, So for wireless sensors that are provided, the process of pairing is pretty simple. It's just pressing a set of buttons on each device and gateways and things work. For heterogeneous networks with other protocols are in use, the gateway provides a discovery service that can look for a variety of sensors that are on attached sensor networks. Of course, some protocols, especially older protocols, require user intervention to create a user matrix for addresses and for configuration of devices. Um, the platform provides a back office that allows all of the configuration of these settings, especially all metadata that relates to the gateway location, to the sensor location, and to make it easy to integrate with the rest of the ENCORE platform. Also, all of the IFC IDs that can relate to the plant of the building as well. A back office is provided for the installation side and the maintenance of the platform. This allows again for installation and configuration of the deployed solution, allows also for real-time monitoring for sensor health, and especially for battery powered ones to be notified when these batteries need changing. Also allows the update of firmware whenever there is a bug fix or an edit service that needs to be added to the platform. So again, just a view onto the virtualized sensor stack. So again, each sensor has a list of properties that reflect not only the properties of the sensor but also the recent readings. So those shown in pink actually show that those values have been just recently updated. All the other ones sometimes are filled in once the sensor is initialized and they are never broadcasted again. Others are broadcasted every so often. The back office all allows if the device as accepts commands as well, it will create a list of the commands that for that specific device, and they can be executed directly from the back office. Other options include filling in details for the metadata for the device and also looking at the current sensor charts. So it shows an update or it shows a recent collection of data from each of these sensors just to make sure that things are operating according to plan. So to integrate within the ENCORE solution, an API has been developed that other services can use to query the different gateways, the different sensors, and extract all of the relevant data they need for that execution. So query parameters as IFC IDs and tags are part of what's on offer through this API, allowing again other services to quickly map between the blueprint of the building and the sensors that are within those spaces as well. Um, it also allows to subscribe for gateway alerts, so the API can still also inform third-party applications through its API if something is going wrong with the sensors, if there is a power failure, or if there is a faulty sensor in location. So as a dashboard has also been created for the users or for the system users, the platform users to explore all the data, to look especially when you're looking at a degradation of values, to do a direct comparison with previous periods and do a comparison between how external factors have been affecting internal factors within the fabric of the building. Again, we're looking at temperature charts, humidity charts, and comparison with previous periods, which can be defined as required. Now we have an illustration of a motion map. So this allows the system to indicate what are the more frequently times of the day where those spaces are used. So this allows creation of a usage profile that then can be used to optimize heating and lighting requirements. An app has also been designed just as a quick reference, indicating not only uh, allowing to explore the graphs with the variation for different sensors, but also giving a user a quick feedback in terms of the comfort parameters using a simple semaphore type indication that from green to amber and red, indicating what the what is the comfort level within a defined space that is being monitored. Thank you for your attention. Apologies for not being available to answer your questions, but if you have any question or any query that you want to send to me, please use the email provided. And thank you for your time once again.